Hello, welcome students for the online lecture on fluid power engineering bearing a code 18ME55. So we will continue the first module, Introduction to Fluid Power Systems. So in module 1, first we will see the contents of the all 5 modules. In first module, that is Introduction to Fluid Power System, we are going to study what is fluid power system, what are the components of the fluid power system, advantages, applications of fluid power systems, transmission of power at static and dynamic states, Pascal's law and its applications, fluids which are used in the hydraulic system, properties of the fluids, which are the different types of additives which are added to increase the properties of the to change the properties of the fluids, different types of seals, seal materials, types of seals, different cross sections, types of pipes, types of hoses, different types of fittings, different types of couplings, fluid conditioning, contaminants, and different types of heat exchangers which are used to maintain the temperature of the fluids which are used in the hydraulic system. In second module, we are going to study pumps and actuators. So we are going to study different types of pumps. So in hydraulic system, we are going to use positive displacement pumps. So there are different types of pumps like gear pump, vane pump, piston pumps, radial pumps, and different types of accumulators we are going to study: spring loaded, dead weight loaded, gas loaded, diaphragm type, bladder type. So which the accumulators are used in the hydraulic system, which will act as an emergency power source, which will act as a shock absorbers, which will act as a leakage compensator. That is the function of accumulators we are going to study, and different types of accumulators we are going to study. Different types of actuators we are going to study in second module. That may be a single linear actuators or rotary actuators, and in linear actuators there are different types like single acting cylinder, double acting cylinder, double rod cylinder, tandem cylinder, and in rotary actuators there are gear motor, vane motor. So we are going to study the different types of actuators which are used in the hydraulic system to do the work. So in actuators only we are going to get the work done. So oil, which is high pressure oil, which is used to do the work, after doing the work in the actuator, it has to be returned to the reservoir. So in third model we are going to study the different types of valves which are used in the hydraulic systems. So different types of direction control valves are used like 2 by 2. 2 by 2 means 2 positions and 2 ports. 4 by 2 means 4 ports and 2 positions. 4 by 3 direction control valve means 4 ports are there and 3 positions are there. So in one position the actuator is extending. If it is rotary, it will rotate in clockwise direction. In center position there is no movement of the actuator, or motor is not running. And in other position of the valve, the motor is going to rotate in anti-clockwise direction. If it is linear type, it will start to retract. In one position it will extend, and in another position it will retract, and in center position it is dual position. There is no movement of the actuator. So different types of valves we are going to study: sequence valve, we are going to study poppet valve, spool valves, rotary type valves, counterbalance valve, flow control valves, pressure compensated flow control valves. So these are the some valves which are used in the hydraulic systems. So we are going to study the how to design the circuits for the given application. So the application may be a lifting of the load, or it may be a punching of the hole in the plate, or it may be a robot moving of the robot arm, or it may be gripping of the component by the robot. So for different applications we must design the different circuit diagrams. So different circuits we are going to study: meter in circuit, meter out circuit, sequence circuit, counterbalance circuit, control of hydraulic motor, synchronization circuits. So different types of circuits we are going to study for different applications. So pneumatic power systems. Fourth module is pneumatic power systems. Introduction to pneumatic systems. Pneumatic power system, advantages of pneumatics, limitations, applications of pneumatic systems, choice of working medium, characteristics of compressed air, and different types of air compressors we are going to study, and structure of pneumatic control system we are going to study here, and fluid conditioners like dryers and filter, regulator and lubricator we are going to study in fourth module. Next, pneumatic actuators, types of cylinders, working and position cushioning, different types of seals, mounting, how the mount the actuators, applications, rotary cylinders, types of rotary cylinders, pneumatic control valves, so direction control valve, poppet valve, spool valve, suspended type, slide valve, pressure control valves, flow control valves, type of constructions, use of memory valve, quick exhaust valve, time delay valve, settle valve, twin pressure valve, and we are going to study the different symbols used to show the components in the hydraulic circuits. And in fifth module, pneumatic control circuits, simple pneumatic control, direct and indirect actuation of cylinders, speed control of cylinders we are going to study, signal processing elements we are going to use the logic gates, and or nor NAND, like that. By using these logic gates we are going to study the building of the circuit diagrams, pneumatic circuits, multi-cylinder applications, coordinated and sequential motion, control motion and control diagrams, cascading method, electro-pneumatic control, pilot assisted solenoid control of direction valves, use of relays and contactors, control circuitry for simple single cylinder. So these are the contents of the 5 module. So now we'll come to the first module, that is introduction to fluid power systems. So let us see the introduction. So let us see importance of the fluid power systems. The basic source of power in industries comes from 3 kinds of sources: electrical, mechanical and fluid power. The use of electrical prime movers such as electric motors and mechanical prime movers such as internal combustion engines is very common. Also, the means of power transmission in this system is well established. For example, the electrical power is transmitted through suitable power cables, while the mechanical power is transmitted using gears, shafts, belts, etc. The third common source of power that is widely used in modern industries is fluid power. High pressure fluids. High pressure fluids, both liquids and gases, can be used to transmit power. So here we are going to use high pressure fluids to transmit the power from one point of source to the point of utilization. So it may be from the it is from pump to the actuators, from point of source to the point of utilization, which in turn can be used to produce rotary or linear motions. Another special application of fluid power is to apply the force on to an object and release the force. Though it is possible to apply forces through some mechanical means, fluid power is the most convenient way. Fluid power systems that use liquids as working medium are termed as hydraulic system. Fluid power systems that use gases are termed as pneumatic systems. So fluid power refers to the branch of engineering that deals with the use of high pressure fluids within confined areas to generate, control and transmit power. So let us see the components of the power system. So reservoir is used to store the oil, filter is used to filter the oil. Next, pump to suck and deliver the oil in the system. To run the pump you require the motor. Next, pressure regulator, direction control valve, and direction control valve to the actuator. It is connected to the actuator. So in after doing the work in the actuator, the oil is going to return to the reservoir. So the components of the hydraulic system are reservoir, filter, pump, pressure relief valve, direction control valve, actuator, accumulators. So these are different components which are used in the fluid power system. So in the figure you can see the three positions. In first position the extension will take place. In center position there is no movement of the ram or that piston on which the load is acting, and in other position the cylinder is retracting. So in one position it is extending, in a center position it is no movement, and in a third position it is retracting. So the load is acting on the actuator here. So here in the figure you can see the linear actuator. You can use the rotary actuators also in the system. So according to the application we are choosing the actuators, whether linear or rotary actuators. There are 6 basic components required in a hydraulic system: a tank to hold the hydraulic oil, a pump to force the oil through the system, an electric motor or other power source to drive the pump, valves to control the oil direction, pressure and flow rate, an an actuator to convert the pressure of the oil, piping to carry the oil from one location to the other. So pneumatic system, let us see the components which are used in the pneumatic system. Here we are going to use the compressor to compress the air. Here air or gas is used in pneumatic system. Air or gas is used as a working medium. So to compress the air we are using the compressor, and to run the compressor electric motor is used. Next, air cooler. When the air is compressed, pressure also increase and its temperature also going to increase. So to cool the air we are going to use the air coolers, and we are going to store the compressed air in the reservoir, and from there it is taken to the system passing through the direction control valve, and it will move towards the actuator to do the work. After doing the work it is exhausted in the atmosphere. So in the hydraulic system the oil which is used, it will return to the reservoir. Here the air after doing the work in the actuator it is exhausted in the atmosphere. So the components of the pneumatic systems are compressor, air cooler, reservoir, direction control valve and actuator. Here also the actuators are linear type or rotary type. And to stop and on the motor we are going to use the pressure switch. Automatically the motor is going to on and off. So when pressure decreases it will start the motor, and when pressure increases and to the set pressure the motor is going to stop automatically. So pneumatic system have components that are similar to those used in hydraulic system: an air tank to store the given volume of compressed air, a compressor to compress the air that comes directly from the atmosphere, an electric motor or other prime mover to drive the compressor, valves to control air direction, pressure and flow rate, piping to carry the pressurized air from one location to another. These are the components which are used in the pneumatic system. Advantages of fluid power system. Fluid power systems are simple, easy to operate and can be controlled accurately. Fluid power gives flexibility to equipment without requiring a complex mechanism. Using fluid power we can start, stop, accelerate, decelerate, reverse or position large forces or components with great accuracy using simple levers and push buttons. So hydraulic systems and pneumatic systems are used to move the tools, components, to move the loads, to cut the seat, to punch the holes, to do the assembly work, to move the arms of the robots, to gripping the components, to open the door of the city buses. So in a universal testing machine, to do the tensile test, compression test, bending test, etc. So multiplication of and variation of forces, linear or rotary forces, can be multiplied by the fraction of a kilogram to a several hundreds of tons. So multiplication of the forces we are going to get here. Multifunctional control in number of machines can be controlled by a single unit. Low speed torque, so we are going to get the high torque with the low speed. Constant torque, we are going to get the constant torque here in pneumatics hydraulic system. Economical, not only reduction in required manpower, but also the production or elimination of operator fatigue as a production factor is an important element in the use of fluid power.